All right, 8th grade, welcome back. We're pushing into investigation 4, and we're getting ready to look at problem 4.1. So hopefully those of you guys that made the Google Meet today, we had a chance to talk through this a little bit. If you didn't, preview some of these problems and help you work on the ACE work as we finish. All right, here we go. All right, so here we go, pumping out water. Magnolia Middle School needs to empty their pool for resealing. Ms. Theodora's math class decides to collect data on the amount of water in the pool and the time it takes to empty it. So here it is. The class writes the following equation to represent the amount of water, W, in gallons, in a pool after T hours. So here's the equation. Let's take a look at that. W equals negative 250 times the quantity of T minus 5. So we're going to be asked to look at some information about what this represents. What information does that negative 250 represent? What units should we use for negative 250? What information does the parentheses of T minus 5 represent? What unit should you use for T minus 5? And what unit should we use for negative 250 times a T minus 5? And understand that as well. Now, this is a little bit tricky for us.
It's really having us to go back and look at a lot of the ways these functions have been structured. Now, we got to remember that when we saw functions, linear had some kind of constant rate being multiplied times a variable, and maybe had something being added or subtracted as a y-intercept. We also saw that exponential functions always had some kind of growth factor or decay factor in a number form, but the exponent was what was up in the, or the variable was in the exponent part. And then these quadratic functions, where we're getting more familiar with recently, is we have some kind of variable there, but the variable is always going to have something to the second power. Those are our main clues to look at. So we're going to need to make sure we remember what each of these are and see if we can realize what kind of functions we're working with here in this particular investigation.
Okay, so I went ahead and wrote down our function. W equals negative 250 times the quantity, in parentheses, T minus 5. So we have some questions to think about before we start. So we have here, answer the following questions. Explain your reasoning. So how many gallons of water are pumped out each hour? I don't know if I could see that. I might be able to see that. How long will it take to empty the pool? I'm not sure about that one either from looking at this. How many gallons of water are in the pool at the start? That's a little tricky too. So what I think I'm going to do is I'm going to actually make a table and just start putting some of this information in. So I'll do that here. I'll have my T is going to be going in first and my W's over here. And then I'm going to draw my table. Okay, so first thing I'm going to look at this. I have an idea what the function structure is, but it looks a little bit different. So I'm just going to plug some values in. So that I'm emptying a pool after a certain number of hours. We're worrying about how long it's going to take in this process. So I'm going to plug in some different numbers here. I'm going to plug in 1, 0, 1, and 2 to get an idea of what's going on here. So if I put in 0 for T, that would end up being a 0 minus 5. 0 minus 5 is going to be a negative 5. And all that still needs to be multiplied times that negative 250. So let's see that. If I've got 250 negative times 5 negative, I'm going to get 1,250. Okay, interesting. I'm going to plug in 1 this time. 1 minus 5 is going to give me a negative 4. And again, times that negative 250. So in this case, let's do that. So I'm going to have 250 negative times 4 negative. I get 1,000. Okay, let's try one more. If I put 2 in here, 2 minus 5 is going to give me a negative 3. All that times negative 250. So here we go. 250 negative times 3 negative. I get 750. Okay, so a little bit of a start here. I kind of see some more questions here that we might be making sense of. So how many gallons of water are pumped out each hour? Okay, well, if I go from 0 to 1, I kind of see that going from here to here, it looks like it's a minus 250 gallons. And then from here to here, minus 250. So I think that's going to be our rate. It's going to be our rate. So I think what we have here for A1, the question is how many gallons per each hour? I think 250 gallons per hour. Okay. All right, number 2. How long will it take to empty the pool? We didn't get that far, did we? How about we take a look at that one here? So I ran out of room. I shouldn't have put that on there. But let's see if I put a 3 in here. Let's try that. So now I know I'm going to have 3 minus 5 is going to be -2, -250. I think I know that's going to be 500, isn't it? Hey, I'm trying to figure this out, this little pattern here. Let me continue that over here. So T and W, same process. I'm going to try 4. So another -250 here. I think it's going to be 250 there. And then after 5, another -250, looks like it's going to be a 0 at that case. So it looks like it's going to be 5 hours. And I think that would make sense because if it's going -250 every single time, we're kind of seeing that pattern go in that case. And then, how many gallons of water are in the pool at the start? Meaning 0 hours have gone by. Well, hey, we did that one too, didn't we? 0 hours going by. Looks like, hey, there's 1,250 gallons at the start. All right, part B. Write an expression for the amount of water in the tank after T hours that's equivalent to the original expression. All right, so B1, they want us to have here, let me write it again, W equals -250 times T minus 5. Now, before we start, remember what we've been noticing. Outside, anytime there's a number outside something parentheses, we've been using something called the distributive property. So we're going to distribute that through all the way. So if I have a -250 times T, that's going to give me -250T. Then I have a -250 times -5. Hey, we actually just did that up here, didn't we? We did that one, which is going to be 1,250, which is going to be a positive because it's negative times negative. So it turns out that ends up being our new expression. And not looking like that, that looks pretty familiar to me. That structure looks like it's linear. And I think we saw that linear process where it's going to be a constant rate of 250 gallons coming out every hour. So here we go. B2. What information does this new expression tell you about the amount of water in the tank? Well, that's pretty straightforward. We can see now because it's linear. It's a linear equation. And we can see that 1,250 is the, what do we call it? The y-intercept. That's what we have there. So that's how we know how many gallons are at the beginning. And which expression is more useful in the situation? Well, it really depends upon your own personality and what you like. Specifically, I like this function much more because it is linear and I visualize it. I see this is the slope. It's a -250. This is the y-intercept. This is how many gallons were in the pool. So I like this one best. That's my favorite. You might like the other one because you don't mind plugging things in, because you might use your calculator and that makes it easier. Either way is fine. But this one I think we're grown accustomed to seeing and working with. All right, part C. Describe the pattern of change in the relationship between the two variables W and T. Okay, so I think we already kind of talked about part of this already. The pattern of change is linear. So pattern of change is linear. And basically what that means so we have here, as T increases by 1, W decreases by 250 gallons. That's what they're asking us to do for that one. And part 2, without graphing the equation, describe the shape of the graph. Include as much information as you can. Well, for me specifically, I would say that without graphing, it makes me want to graph it, but because we have a y-intercept up here, I can envision having the x and y axis already drawn, and we'd have the negative or positive 1,250 be y-intercept up high, and we'd have a -250 kind of coming down, so it'd be a straight line going down towards the right. Down towards the right, and when we actually get to 5 hours, it'd be at 0. That's how we would describe that. Part D. We have another situation very, very similar to what we just had for all of A, B, and C, but now they're giving us another one here for part D. Suppose the equation for the amount of water W in gallons in the pool after T hours is W equals negative 450 times quantity of T2 times T minus 7. And they want to know how many gallons gallons of water are pumped out every hour. How long does it take to empty the pool? How many gallons are at the start of the process? And then write an expression. So I don't know about you guys, but I think I want to do this in a different order. I like writing a new expression first so we can actually see that. So let me do that here. So the new equation is going to be W equals negative 450 times 2 times T minus 7. So I'm going to do this out of order like we do sometimes. So this is going to be number 4 first. I'm going to distribute this through so we can see. So you can see I've got negative 450 times 2T. Well, negative 450 times 2 would be negative 900. So I'm going to have here a negative 900T. And then I'm going to have my other distributive part going through here with that negative 450 times the negative 7. So if I do that, 450 negative times 7 negative, it's going to give me 3,150. That's going to be positive because they're both negative, so 3,150. So now I look at this, that makes answering the other ones a lot easier. Okay, how many gallons of water are pumped out each hour? Okay, for number 1, 900 gallons per hour. 900 gallons per hour. Number 2, how long will it take to empty the pool? Ooh, that's a good question. We need to work our way through and see that process to get to all the way out. Now, we earlier did a table to figure out how it's all going to be gone, but this is going to be a little bit different. So we might need to plug some numbers in or figure this out, or we could actually, like we did in the last problem, set W equal to 0. Like 0 would mean the water would be gone. So let's actually do that way instead. So if I have here 0 is equal to negative 900T plus 3,150. So same process of solving equations. So minus 3,150 here, minus 3,150 here. This is going to cancel. So I'm going to having a negative 3,150 is equal to negative 900T. Again, same process. Divide both sides by negative 900. Divide by negative 900. This will be a big giant positive T. And if I have that here, and make sure this is negative, divided by 900, that's negative. There we go. Hey, look at that. It's going to take 3.5 hours. So that means 3.5 hours to drain. There we go. And number 3, how many gallons of water in the pool at the start? Well, going back to our new function format here, you saw when we did it before, that's our y-intercept. So you can see 3 is going to be 3,150 gallons at the start. Sorry, I left out one part here for number 4. So we wrote that expression at the very beginning. Then which expression is more useful, and explain?
Personally, and again, I know this is my preference, I love seeing those equations in slope-intercept form because it just tells me so much information right away. I can automatically know what the rate is because I see the slope, and I can automatically know what the starting point is because I can see the y-intercept. So that gives me answers right away. How many gallons are pumped out each hour? What's the water at the start? And I can just do some work there. So I prefer the slope-intercept form, but it might be different for you. You can choose whatever you like.
All right, guys. So for this assignment, we're going to be the ACE numbers 1 through 4, 25 and 28, and 56. Now, I'm really only wanting to have you guys work on this 1 through 4. For sure do those. But the 25 to 28 and number 56 is what we're definitely wanting to do. At number 1, here it is. It's another pool. Negative 275T plus 1,925. There it is. All the different work there. Then here's another one. A new pump for the pool, exercise 1. W equals negative 275 times 2T minus 7. Same kind of process. Then you have a truck that's a broken fuel gauge. There's the equation already. Same process. How long is it going to take to get empty? And then finally, you have information about a yearbook, order forms, and making sure that you understand, here's the equation down here. That's really what it boils down to.
All right, 8th grade. Hopefully that's well explained and you guys are doing okay with that. If you have a chance to be at the Google Meet today, we can talk through that as well. But if you also need to go back and pause the videos, it's a good way to have both resources. Hope to see you guys later on or in the future. Hang in there, guys.